Let's keep adding and subtracting square roots. Here we have the square root of 18n to the fifth minus 32n to the fifth. And since these radicands are different, we've got to simplify to make any progress. So I'll rewrite this as the square root of 9 times the square root of 2, because that's 18, times the square root of n to the fourth times the square root of n. This is getting jammed in here a little bit. And this is all related to 18n to the fifth. What a mess. If I simplify just this part down, I'm going to get 3 square root of 2 n squared and root n. Cleaning it up just a little bit, 3n squared, the stuff outside the square root, times the square root of 2n, the stuff inside. Let's deal with this other part over here. 32 is 6 square root of 16 times the square root of 2. And we know n to the fifth is the square root of n to the fourth and the square root of n. So cleaning up each part, we get 4 times the square root of 2 times n squared times the square root of n. And bringing it back into the problem, it'd be minus 4n squared times the square root of 2n. Now we can see that these 4n squared, we can see that these are like terms. They both have the same radicand. And 3n squared minus 4n squared is negative 1n squared. So negative n squared times the square root of 2n. There's a lot to keep track of here. Why don't you try another one? Why don't you try the square root of 32 m to the 7th minus the square root of 50 m to the 7th. Let's see how you did. Now I'm going to use the Orndorff method to help me out a little bit. The square root of 32 is the square root of 16 times 2. And m to the 7th, well, 2 goes into 7 3 times, so it'd be m cubed with m left over minus the square root of 50 is 25 times 2. And it's m to the 7th again, so I know it's got to be the same thing, m cubed times the square root of m. Again, I use the Orndorff method. The square root of 16 is 4, so this would be 4 times m cubed times the square root of 2m, because these are the things left inside the radicands. And this would become minus 5m cubed times the square root of 2m. And again, altogether we have negative m cubed, there's only negative one of them, square root of 2m. A lot to keep track of. Let's try one more like this. Two square root of 8x squared minus 5x root 32 plus 5 square root of 18x squared. Hit pause and give it a shot. Well, I know for this first term it would be 2 times the square root of 4 times 2 times x squared, which means this is 2 times 2, because that's the square root of 4, times the square root of 2 times x. We're all together 4x root 2, getting it in the proper order. The second term, well, 32 is 16 times 2, which means this is negative 5x times 4 times the square root of 2. or altogether negative 20x times the square root of 2. Now our third term, plus 5 times the square root of 9 times 2 times x squared. But the square root of 9 is 3. Square root of 2 times x. Cleaning it up, 15x root 2. And now we can see that these are all like terms. And 4x minus 20x is negative 16x, plus 15 happens to be negative 1x times the square root of 2. And no, it's not always going to be negative 1. It's just, for some reason, that's how all these problems have worked. Be careful. There's a lot to keep track of, but I know you can do it.